Everyone believes the sun is burning. You learned it early, long before you understood physics or chemistry. Somewhere between childhood drawings and school textbooks, an image settled into your mind, a giant ball of fire hanging in the sky, blazing endlessly above Earth. It feels obvious. Flames give light. Flames give warmth. The sun gives both. The conclusion seems natural. A fire in the heavens. For thousands of years, humanity accepted this idea without question because fire was the most powerful force we understood. Fire cooked food, protected us from darkness, and pushed back the cold night. When ancient people looked upward and saw the brilliant disk crossing the sky, they recognized something familiar. It glowed like fire. It warmed like fire. It behaved, at least from a distance, like the largest flame imaginable. And so the metaphor became belief. Even today, despite modern education and scientific discovery, somewhere deep in your intuition the sun still feels like an enormous burning object, a cosmic furnace slowly consuming fuel to keep shining. It is an idea so deeply embedded in language that we still say the sun burns, without ever stopping to question what that word truly means. But here is the astonishing truth. The sun has never burned, not once, not for a single moment in its entire 5 billion-year lifetime. Fire as you know it cannot exist there. Fire requires oxygen. Fire consumes material. Fire inevitably fades when fuel runs out. Every flame you have ever seen carries within it the certainty of extinction. Yet the sun shines with unimaginable consistency, releasing more energy every single second than all of human civilization has produced throughout history combined. Day after day, century after century. Billion years without pause. No chemical fire could sustain that power. No fuel known to chemistry could survive even a tiny fraction of that time. So something profoundly different must be happening above your head right now. Something stranger than flame, deeper than combustion, and far more fundamental than anything humans once imagined. The light warming your face is not the glow of burning fuel. It is evidence of a process so extraordinary that understanding it changes not only how you see the sun, but how you see your place in the universe itself. And once you understand what truly powers the sun, the sky stops being familiar and becomes astonishing again. Long before science existed, the sun was humanity's greatest mystery. Every morning it rose with perfect reliability, pushing back darkness and bringing warmth to a fragile world. Every evening it disappeared, leaving uncertainty behind. To early humans, this rhythm felt intentional, almost alive. The sun was not just an object in the sky, it was a presence, a force that governed survival itself. Civilizations formed their understanding of reality around it. In ancient Egypt, the sun became Ra, a divine being sailing across the heavens each day. Temples were aligned precisely with sunrise, and entire calendars were built around its movement. The sun dictated agriculture, seasons, and ritual. To question it was to question existence itself. Across the Mediterranean, Greek thinkers began to move away from mythology toward explanation. Instead of asking who the sun was, they asked what it was. In the 5th century BCE, the philosopher Anaxagoras proposed something radical. The sun was not a god at all, but a physical object, a massive glowing stone far larger than anything on earth. The idea was revolutionary. It stripped the heavens of divine perfection and replaced mystery with inquiry. For this he was mocked and eventually exiled. Yet his mistake was not daring too much. It was that human knowledge had not yet advanced far enough to confirm how close he was to the truth. Other thinkers offered their own models. Aristotle imagined the sun composed of a perfect celestial substance called ether, fundamentally different from earthly matter. Later scholars constructed elaborate mathematical systems to predict its motion, mapping the sky with astonishing precision, while still lacking an explanation for its power. The deeper question remained unanswered. Why does it shine? Generation after generation inherited the same puzzle. The sun radiated immense energy endlessly, yet nothing in human experience behaved that way. Every source of light known to humanity eventually weakened. Torches burned out, oil lamps dimmed, even the largest fires collapsed into ash. And still the sun endured. By the time scientific thinking matured in the modern era, curiosity turned into calculation. Scientists no longer asked only philosophical questions. They began measuring the sun's energy. When they finally calculated how much power it released every second, the result shocked them. The numbers did not merely challenge existing theories, they shattered them. For the first time, humanity realized that whatever fueled the sun was unlike anything ever discovered on Earth, and solving that mystery would require rewriting the laws of nature themselves. By the 19th century, humanity believed it finally understood nature. Physics had explained motion, gravity, heat, and light. The Industrial Revolution proved that scientific laws could reshape the world itself. Engines ran, factories moved, and energy could now be measured, calculated, and predicted with remarkable precision. For the first time, scientists felt confident enough to ask a dangerous question: exactly how much energy does the sun produce? When the calculations were completed, the answer was staggering. Every second, the sun releases more energy than humanity has generated in its entire history, more power than billions of cities running simultaneously. And it does this continuously, without interruption, without visible loss of brightness, without any sign of exhaustion. The numbers created a crisis. Because once scientists knew the sun's energy output, they could estimate how long any known energy source could sustain it. If the sun were burning like a fire, fueled by chemical reactions similar to coal or wood, it would exhaust itself astonishingly quickly. Even if the entire sun were made of the most energy-dense fuel known at the time, it could shine for only about 10,000 years. But Earth itself told a different story. Geologists were discovering rocks hundreds of millions, even billions of years old. Fossils revealed an ancient history far older than a chemically powered sun could allow. Life had clearly existed for vast stretches of time, meaning the sun must have been shining far longer than physics seemed to permit. Science faced an impossible contradiction. Either geology was wrong, evolution was wrong, or physics itself was incomplete. One of the greatest scientists of the era, Hermann von Helmholtz, proposed a solution. Perhaps the sun generated heat by slowly contracting under its own gravity. As it shrank, gravitational energy would convert into heat and light. The idea was elegant and mathematically sound, but it failed. Even a collapsing sun could only shine for about 20 million years, still far too short to explain Earth's ancient past. The mismatch was undeniable. Something fundamental was missing from humanity's understanding of energy itself. The sun had become more than a mystery. It was a crack in the foundation of science, proof that the universe operated through processes deeper than chemistry, deeper than mechanics, deeper than anything yet discovered. And into that crack, at the dawn of the 20th century, a completely new vision of reality began to emerge, one that would reveal that energy and matter were not separate things at all, but different forms of the same cosmic substance. At the beginning of the 20th century, physics stood on the edge of revolution without realizing it. For centuries, matter and energy had been treated as completely separate ideas. Matter was substance, solid, measurable, permanent. Energy was action, motion, heat, light. One could transform into another form of energy, but matter itself was assumed to be unchangeable, an eternal foundation beneath reality. That assumption was about to collapse.
A young physicist named Albert Einstein published a paper containing a deceptively simple equation: energy equals mass multiplied by the speed of light squared. The equation did not merely describe a relationship, it revealed an identity.
Mass and energy were the same thing expressed differently. Matter was frozen energy. Energy was liberated matter. At first, the equation seemed abstract, elegant mathematics without obvious application, but hidden inside it was the answer to the sun's impossible longevity. If even a tiny amount of mass could transform into energy, the resulting power would be enormous. The speed of light is unimaginably large, and squaring it multiplies that magnitude beyond ordinary comprehension. Suddenly, scientists realized that the sun did not need to burn fuel in the chemical sense at all. It could shine by converting matter itself into energy. The question shifted from chemistry to the atom. Inside every atom lies a nucleus, tightly bound by forces far stronger than anything experienced in everyday life. Physicists began uncovering these forces piece by piece, discovering that atomic nuclei contained vast stores of potential energy. The challenge was understanding how that energy could be released naturally inside a star. The answer emerged through quantum mechanics, a new framework describing reality at the smallest scales. In this strange domain, particles do not behave like solid objects. They exist as probabilities, capable of doing things classical physics forbids. One of those phenomena is quantum tunneling. Normally, positively charged hydrogen nuclei repel each other intensely. The electromagnetic force creates a barrier so strong that under Earth-like conditions nuclei cannot merge. They collide and bounce apart endlessly. But quantum mechanics allows a rare and remarkable exception. Particles can sometimes pass through barriers instead of climbing over them. Inside the sun's core, temperatures reach about 15 million degrees Celsius, and pressures are immense beyond imagination. Hydrogen nuclei move at extraordinary speeds, packed so densely that occasionally, not often but often enough, quantum tunneling allows two nuclei to come close enough for another force to take over. The strong nuclear force. When this force acts, the nuclei fuse together, forming a heavier nucleus. Through a sequence of reactions known as the proton-proton chain, 4 hydrogen nuclei ultimately combine to form one helium nucleus, and something astonishing happens. The helium nucleus weighs slightly less than the 4 hydrogen nuclei that created it. A tiny fraction of mass, less than 1%, disappears. But it does not vanish, it transforms directly into energy, exactly as Einstein's equation predicts. That lost mass becomes light, heat, and radiation. Every second the sun converts roughly 600 million tons of hydrogen into helium. About 4 million tons of mass are transformed entirely into energy each second, flooding space with sunlight. This process is called nuclear fusion, not burning, not combustion, but a transformation occurring at the deepest level of matter itself. Chemical fire rearranges electrons. Fusion reshapes the nucleus. Fire consumes fuel and leaves ash behind. Fusion builds new elements while releasing energy millions of times more efficient than any chemical reaction. The sun is not a giant flame. It is a self-sustaining fusion reactor powered by the laws of quantum physics and gravity, working together in delicate balance. At last, the ancient question had an answer. The sun shines because matter itself is slowly becoming light, and with that realization humanity understood something profound. The energy warming Earth, driving weather, feeding plants, and sustaining life is born from processes occurring deep within atoms, processes that connect the smallest scales of existence to the vast architecture of the cosmos itself. The mystery of the sun had not only been solved, it had revealed a universe far stranger, more unified, and more beautiful than anyone had ever imagined. Now pause for a moment and consider what this truly means. Every ray of sunlight touching your skin began its story deep inside the sun's core, a region so dense and hot that matter exists as plasma, atoms stripped apart into charged particles moving in chaos. There, through nuclear fusion, energy was born when mass itself transformed into light. But that light did not escape immediately. A photon created in the sun's core does not travel straight outward. Instead, it begins a long, wandering journey. It is absorbed, re-emitted, scattered, redirected countless times by particles in the dense solar interior. What should be a 2-second escape becomes a slow, random walk lasting tens of thousands, sometimes hundreds of thousands, of years. The sunlight you feel today may have started its journey before human civilization existed, before cities, before agriculture, before language took written form. Only after that immense internal journey does the photon finally reach the sun's surface and launch into space, crossing the empty vacuum at the speed of light. 8 minutes later, it arrives at Earth, ending a voyage that began long before history itself. And then something extraordinary happens. That energy does not simply warm the ground, it becomes part of life. When sunlight strikes a leaf, molecules of chlorophyll capture its energy, water splits, carbon dioxide rearranges, sugars form, plants grow. Those plants become food, oxygen, ecosystems, the foundation of nearly every living system on this planet. The energy released in the sun's core flows through forests, oceans, and atmospheres until eventually it becomes motion in your muscles and electrical signals in your brain. Every thought you think is powered by ancient starlight. You are not merely living under the sun. You are participating in a continuous chain of transformation that began inside a star. The atoms forming your body were forged in earlier stars that lived and died long before our solar system formed. The energy sustaining you right now was created through fusion reactions converting hydrogen, the simplest element in the universe, into something capable of awareness. In a very real sense, you are the universe learning about itself. For much of human history, the vastness of space made people feel small and insignificant. Compared to galaxies and cosmic distances, human life seems brief and fragile. But scale alone does not determine importance. Complexity, consciousness, and understanding arise from the same cosmic processes that ignite stars. The universe evolved from simple particles into atoms, from atoms into stars, from stars into planets, and from planets into minds capable of asking questions. After billions of years of transformation, hydrogen has arranged itself into something that can look upward and wonder why the sun shines. That question is not separate from the universe. It is the universe speaking through you. Our sun is only one star among hundreds of billions in the Milky Way, and our galaxy is only one among trillions scattered across the observable cosmos. Everywhere, stars are performing the same quiet miracle, converting mass into light, illuminating worlds that may or may not host observers capable of noticing. Yet here, on this small planet, awareness emerged. You exist at the meeting point between cosmic forces and conscious experience. The warmth on your face, the light in your eyes, the energy moving through your body, all of it connects directly to processes unfolding 93 million miles away. The sun does not simply shine, it creates possibility. And perhaps the most profound realization is this: the story of the universe is not something happening far away in space. It is happening through you, right now, in every breath, every thought, every moment of curiosity. So the next time you look at the sky, remember, you are not standing apart from the cosmos. You are one of the ways it has learned to see itself.